Hi, my name is Eric Dune. I am applying for a physics science teacher position, virtual position. I want to start by saying that I apologize. This is a Zoom recording, not an Adobe Connect recording. I have been trying to get Adobe Connect to work for the last 24 hours. I finally resigned and said, you know what? I'll make a Zoom recording, and if this isn't good enough, well, or you're unsympathetic to my cause, well, then uh, I'm willing to try to get Adobe Connect to work, and I've been trying. I've been doing troubleshooting for yesterday and today, but just haven't been able to get it work. So if you could point me in the right direction, that'd be great. But otherwise, uh, here we go. So this is my application for a physics science teacher position. A little bit about me, just get started off. I enjoy running and golfing, fishing. That star right there, I live in northeastern Wisconsin. And so, up here into Northwoods, we talk a little funny sometimes, and and I love being up north, and just being outside and enjoying the great outdoors. Some of my favorite movies are The Princess Bride and Schindler's List, Forrest Gump, and love reading the Chronicles of Narnia with my kids. And we are gearing up to read Lord of the Rings together. And my own personal pleasure is to read the Sword of Truth series by Terry Goodkind. Why should I be considered for this position? Well, I am looking at transitioning more permanently into the online space. This is an exciting new beginning. This picture is a picture of me at the beginning of Highway 1 in Key West. So it's a new beginning, and just trying to get something new going for the next school year. However, I have been teaching online for the last 4 years. I've been teaching in the classroom for 5 years. Um, I am fully licensed to teach all math and all science for middle school and high school in Wisconsin. And I have 3 science degrees, so my content knowledge is very deep. A bachelor's in natural science with minors in physics, chemistry, and math, bachelor's in physics education, and a master's in chemistry with an emphasis in chemistry education. The uh, the lesson that I wanted to go over today is on uncertainties in measurement. This lesson, in this lesson, I will cover accuracy and precision, comparing them. And we are also going to look at number of significant figures in a given number and how to identify, given a number, how do I figure out how many sig figs or significant figures there are in that number. So in accuracy versus precision, when you think accuracy, you want to think how close is that to the standard value. That is like the textbook term, but in regular sense, what is my target, right? That's how accurate you are. If I am accurate, then I can hit the bullseye in a dartboard, or I can make the ball in the basket, right? Because that's the goal. Precision, on the other hand, is the degree of exactness. What does that mean for sports? Because sports is huge, accuracy versus precision. I had a student, and her whole thing was she could hit the net very she could make a lot of baskets, and in a game she was both accurate and precise because she had a very high shooting percentage. However, somebody who is accurate may hit the center, but if they're not precise, they won't hit the center very often. A precise shooter who is not accurate may be off of target consistently. And so here are the 4 combinations of accuracy and precision. High accuracy, high precision, you are on target every time. You hit the bullseye every time. For low accuracy and high precision, you see here that they're very close together, but they're consistently off. And so this, for like a measurement, maybe it's a scale that consistently reads too high or too low, right, in science. For high accuracy, low precision, everything is grouped in the center, but it's a very loose grouping. So if I was performing an experiment in the classroom, then it would mean that I'm getting the right answer, but I'm also getting wrong answers. And so when I average them, they'll come to the middle and come to what's correct, but my answers will be all over the place. Low accuracy, low precision. There's a lot of work that would need to be done in a science classroom, in a physics classroom. We need to look at what's going wrong and why. It could be operator error, it could be the machine's fault. In basketball, this would mean, like, I'll throw it up and I don't know, is it gonna hit the target? Is it gonna go in the basket? Who knows? For high accuracy, low precision, every time I shoot, it's getting close to the basket, but it's not getting in the basket every time. High accuracy, high precision, that is 100% of the time when I throw that ball up to go in that hoop, it will go in every time. And high accuracy, low accuracy, high precision, that's like I'm gonna hit the backboard, the top right corner of the backboard every single time, which would be kind of silly. The second thing I wanted to talk about with you is significant figure, or sig figs. There are 4 main rules for significant figures. Non-zero digits are always significant. All final zeros after the decimal are significant. Zeros between significant digits are significant. And zeros used solely as placeholders are not significant. Now, since this is a video, you could go ahead and pause it right now. And since this is recording, if I was teaching this asynchronously, you would go ahead and pause it right now and write these down. But I've got an even better way. So go ahead and pause if you want, but otherwise I've got a way easier way for you to do this. It's called the Atlantic Pacific rule. Now, in order for us to understand this, we need to understand where the Atlantic Ocean is. It's right here, Atlantic Ocean, and the Pacific Ocean is over here. Okay, so Atlantic Ocean is on the right-hand side, Pacific Ocean is on the left-hand side. So for the Atlantic Pacific rule, if the decimal is absent, you start on the Atlantic side. And I'm going to explain what this is, and I'm going to draw it out for you. So on the Atlantic side, if I start on the Atlantic side, I'm going to take, I'm gonna do this in red. If I'm gonna start on the Atlantic side, I'm gonna put my pencil down and I'm gonna draw a line till I hit the first number that's not a 0. Every other number is significant. That's it. That's all you gotta do. So for this first one, we're looking at 3 significant digits. See that? I got 3 digits there. I started on the Atlantic side. I drew a line all the way till I hit that first non-zero number. When I hit that first non-zero number, everything else is significant. Okay, and that's our goal. Identify significant figures. So for the second problem, I'm going to do the exact same thing. There's no decimal. So the decimal is absent. Absent Atlantic. Absent Atlantic, start on the Atlantic side. You're going to put the pencil on the paper. You're going to draw till you hit the first non-zero number. That means I go straight through that 0. I circle the rest. So here I have 4 significant digits. Now, if you go back to the other slide, this is following those rules, but this is a much easier way. All right, and lastly, you can pause and work this one out if you like before I do it. Otherwise, go ahead and follow along. So go ahead and pause. Moving on. So 3, 4, we're going to decimal is absent. Start on the Atlantic side. Put the pencil down. Go through any zeros. First non-zero number. The rest of our digits are significant, including that 0. So in the second problem with the 0 in the middle, for the third problem with the 0 in the middle, still significant. That is still a significant 0. So 32502, that is 5 digits. That's it. And there will be some practice here in just a little bit. So you can go ahead and fast forward to that and work on it if you want. Otherwise, we're going to move on to the Pacific rule. So for the Pacific rule, if the decimal is present, you start on the Pacific side. Present Pacific. And I'm going to annotate this just like I did before. If the decimal is present, you start on the Pacific side. So put the pencil down, go through any zeros, you hit that first non-zero digit, everything else is significant. Present Pacific. So this is 3 again. For our next problem, we're going to do the exact same thing. Start on the Pacific side, go to the first non-zero digit, circle the rest. I got 5 digits here. That's the 0 after the decimal. That's the 0 in between the 9 and the 2. It's all significant. Those are all measured numbers. And lastly, for the third one, Pacific, present. Decimal is present. Start on the Pacific side. Put the pencil down. Go through any zeros. So you hit that first non-zero number. Everything else is significant. All those digits after. So here we got 5 significant digits. That's it. These are following those 4 rules from before, but it's just that much easier. So here's some practice. And I'm just going to go ahead and go ahead and work your way through these. Pause the video. Here I would walk through some more practice, going every other, and then here are the answers. So go ahead and do the practice. Here's the answers. So now you know how accuracy and precision are different, and you can compare them, what high accuracy versus low accuracy, high precision versus low precision, and how they're related, and you can identify significant digits. Thank you very much. Thank you for your consideration. I apologize for the lateness of the video, and I hope to hear from you soon. Thank you very much. See you next time.